Hey everyone, this is FixReef, and today we have a water-damaged Apex EB8 up for repair. I just received it, I haven't had a chance to plug it in. I don't want to plug it in since it's water-damaged, who knows what's inside. So let's take it apart, see what's going on. Older EB8 units are tougher to take apart than the newer ones, the EB832s. They're much nicer construction because they're made of metal, but they're also a little bit awkward. So that screw went in after the label was put in place, so somebody already took it apart, possibly because of the water damage trying to dry it up. Again and again, putting it in rice, as I've seen things like this before, isn't going to help. Once salt water gets in there, the corrosion begins. You do want to dry it up, but rice is not going to do it any good. Not sure if this was the case with this EB8. Okay, looks fairly clean to me. Looks almost brand new. I do see a little bit of drops of, I guess, water over here, but not a whole lot of corrosion, to be honest. Looks pretty clean. It looks like there is some corrosion on the other side here by the pins, programming pins over here. There is a little bit of oxidation inside of the USB ports, but aside from that, not bad. Okay, next, before I plug it in to test what's going on, I'm going to test a few things on the USB or on AquaBus ports. Let's get the multimeter, and I would like to know with this whether or not there is a continuity across USB pins, because there is some damage there. Okay, EB8 is not actually plugged into power, so it's safe to touch it anywhere. Let's see. Let's see what we get on the power. No direct shorts. Everything checks out. Okay, mostly checks out. Let's plug it in. Nothing shorted. Let's see if the LED is on. I'm not sure if you can see this, but the LED is blinking orange. So far, so good. Let's find out what kind of voltages we get. 5 volts stable. Very good. 5 volts. 5. 5 coming into the CAN transceiver. Okay, this thing is live right now, so I'm not going to touch it too much, but this is all low voltage area over here, so we should be okay. I'm going to go ahead and drop a few drops of alcohol to see if anything heats up. Let me zoom in so that you guys can see it as well. Okay, the first question we need to answer is, how bad is the controller? Seems to be okay. Nothing's evaporating super fast. Let's try diodes. The diodes are also okay. Let's try the CAN transceiver. Ooh, the CAN transceiver is heating up substantially. Look at this. Alcohol evaporates almost immediately. And no matter how much more I put on there, it is gone within a millisecond. Okay. So our main suspect here would be the CAN transceiver. So this is consistent with what I've seen before. Usually when there is a short through the USB ports, whatever that short is, it might be in this particular case, it looks like a bit of a water damage. It shorts 12 volts that are not supposed to be there, that Apex decided to put in as the power supply for everything over USB ports. So it shorts the 12 volts onto the data pins, which goes into the CAN transceiver, which only handles 5 volts and not 12, which usually shorts things out. So my main suspect right now would be the CAN transceiver here. Okay, so far on this EB8, we've determined that the CAN transceiver chip is getting very, very hot. It's a common issue, not just with EB8s, but also with EB832s. There are some other videos that I have on EB832 problem with this similar chip. It's a different chip, but the functionality is the same. Go and watch those if you would like. But since this guy is getting hot, likely the problem, we're going to go ahead and replace this chip now and see if this EB8 is going to start working again. So this CAN transceiver is actually an older model compared to what's in the newer Apex units. It's a 5-volt unit. You cannot put the newer 3.3 volt unit in here and expect it to work. So I'm going to need to get the part that's going to be compatible with this older model of EB8. All right, let's see. I think one of these should work. All right, next we're going to get under the microscope and have it swapped out. We might as well add a little bit of flux just to let the solder flow a little bit easier as we remove it. This is indeed one of the easiest problems to solve with EB8. EB8s are much harder to fix, believe it or not, than EB832s because some of the problems are on the other side of this board, and it's a major pain to get to the other side of this board. There's a lot of outlets that need to be removed, and they don't come off easily. The controller came off. Now would be a good time to have it cleaned up. Remove all of the unleaded solder and replace it with nice and leaded one. Okay, so before I reinstall the CAN transceiver, I'm going to check some pins here for short because in case it was water damaged and there is still some oxidation going on in short, it will blow up the brand new controller. So before I install it, let's check. So I'm expecting that now that the chip is gone, there would be kilo ohms, at least if not mega ohms resistance across the CAN pins, the middle two pins. And here we only have 1.7 kilo ohm. That's not a whole lot. I think there is a problem. Let's test this to the power pins, the 12 volt pins on the outside. So 12 volt pins themselves, about 300 kilo ohms, 250, that's okay. Let's see. This should be in mega ohms. What's going on? Oh no. 1.8 kilo ohm. There is a short. Oh, 3.6 ohms to this pin. Oh no. Yeah, there is a short. Yeah, there is a short. This is what did the original CAN transceiver. There is a short on the pins somewhere. We'll need to find out where it is. Okay, so all of the damage is on the other side of this board, so we'll need to remove the top cover before we can continue. Okay, so to find out what's going on with the AquaBus ports, I ended up taking off all 3 USB ports. And underneath I found a mess. So let's zoom in a little bit so that you can see. So first off, some of the pins broke off. They basically have, as you can see, they have the corrosion damage, and now that pin is missing. For the most part, it's all gone. Other pins seem to be okay, but that indicates that the issue was in the middle, for the most part, was in the middle port here. And indeed, if we look, we can see that the most damage is over here, with a little bit of damage over here. So I'm going to get under the microscope and see how bad everything is here, because that will determine whether or not it's worth saving. Okay, you should see what I see now, which is a lot of mess. Let's clean it up a little bit. to find out how bad it actually is. One of the tricks to try to solve this, to fix this, is to actually use the iron to heat it up to the point where it's going to start, all of the corrosion starts falling off. I'll add a little bit of flux. And let's do it. I'm getting solder out. That's always a good sign. Yeah, there's some shine underneath all of this. Except perhaps for this one, maybe even this one. Okay. One pin must have corroded pretty badly, but rest, oh, and even this. Oh yeah, that's gonna be fixable. That actually looks pretty good. On this surface anyhow, everything looks really good. Let's get rid of the mess. Let's see if it actually reveals a nicer surface. Oh, look at this. This actually looks really nice. A bit more mess up above, which is cleanable. So there was a short over on this trace over here. You can see that some of it burned out. Also repairable. The power trace ends right here. And good copper gonna be starting here. So I can run a trace in no time to connect here. Okay, and let's clean this side. Let's see if this side is going to be as good. If this is going to be as good, this is going to be an easy repair. There's some clean pads underneath as well. A nice scrub. And that's also clean. Hey, look at this. This turned out really good. This needs one trace repaired and this is fairly clean. Okay, so before we reinstall this USB ports, I'm gonna fix the missing trace, and then we're gonna have to test for continuity and resistance. All right, so instead of trying to attach it to the bed pad, I'm going to go ahead and attach it to the middle over here. Okay, that should do it. What's remaining is cover it so that there is no short to the ground or anything else. For this, I'm going to use a bit of green mask. Of course, it'll be good to remove the mess and the flux first. I'm also going to restore some mask over here. A little too much. We'll cure it and be right back. Okay, now that everything is cured, let's check for continuity and resistance on USB pins. Let's check for resistance. Mega ohms across power. Mega ohms across data. Data to power. Mega ohms. Data to power. Mega ohms. This one is mega ohms. And this is mega ohms. Just to make sure that everything is like that. And it appears that this was supposed to be in ohms because I'm touching the same pin basically on the both ends. But yeah, this looks really good. I think we got rid of all of the shorts. I'm going to replace some of the USB ports because obviously the other ones got damaged. These are not new, but they're in a much better condition than the other ones. Third on this end. Fits like a glove. Now this. This is going to be the tough one because that's the one where we have replaced. Oh, it's not tough at all. Goes in easily. Excellent. And the last one. All right, everything fits perfectly. We will align them and make sure that they're all lined up in a bit. Need to do a little bit of cleanup. Should have done it earlier, but forgot. Now, while they're partially secured, this is the time to align. Okay, they look pretty good. Finish up. We are done with the USB ports. Now we have to put the CAN transceiver back in place, and then we can try to safely plug it in. Okay, so we'll need a little bit of flux. It's in place. Now final cleanup. Looks really clean. And at last, the test time. I'm gonna plug it in, see if anything smokes. Let's see if the lights come up. And if everything checks out, we'll see if it connects to the apex. The power is on. Let's test some voltages. I'm expecting 5 volts. Perfect. I'm not seeing any smoke, I'm not seeing any fire, I'm not seeing any sparks. The LED light is blinking orange. Can't show it, unfortunately, because of the angle, and since it's plugged in, I don't want to touch it much. Now let's plug it in and see if Apex recognizes it. I heard a click. Let's take a look at what Apex has. Okay, let's see if we got the new. Yep, EB8 is here. That's great. The tiles are on. Let's switch some outlets. I heard some clicks on relays. So only 2 relays are going to click. The first 2, I think. Oh, actually no. Number 8 and number 4. 8 and 4 are going to click, so those work. Others I'm going to test later. But it seems to be working. Okay, this completes the repair. Let's see what we've done. We had a water-damaged EB8 that came in initially with just a heating or overheating CAN transceiver. It's not uncommon for CAN transceivers to fail, so my initial thought was that if I just replace the CAN transceiver, it's all just going to work. I was wrong. The CAN transceiver was more than likely busted, but it was busted because there was significant corrosion on USB ports, which we couldn't see on the other side of this. So we removed the USB ports, replaced those that were badly corroded, restored burn traces, and it looks like it's now working properly. What I'm going to do after this video is I'm going to test each individual port to make sure that it gets power, make sure that the data transmits, and as long as everything checks out, this repair is complete. Thanks for watching. If you enjoyed this video, please like and subscribe, and I will see you next time.